Hello! Last time, we proved that any social welfare function with all the good properties is a dictatorship. Recall that a social welfare function outputs a ranking of the candidates based on voter preferences. A normal election looks more like a social choice function, which selects one candidate to represent the preferences of the voters. So, can we do better with a social choice function? Well, just like the social welfare functions, there cannot be a social choice function with good properties without the bad. There is only one good property that we want in a social choice function, which is strategy-proof. This means that a voter cannot change the society's choice to something they like better by changing their preferences. We say that F can be strategically manipulated by voter I if there exists two candidates A and B, a voter preference in L to the n, and some alternate preference for voter I such that voter I prefers B over A, the society picks A, and the society picks the one that voter I likes better, which is candidate B, when they change their vote. And we say that F is strategy proof if F cannot be strategically manipulated. And the reason why we want a strategy proof mechanism is that it will ensure the voters vote truthfully, as they cannot change their vote to make the system pick a winner they like more. So truthful voting is their dominant strategy. So that is the good property that we want. And here comes the bad property, which is once again dictatorship. This means that there exists a voter I such that F will always choose the candidate at the top of voter I's list. And if F is a dictatorship, then there is no point in voting. Only one person decides who the winner is. And just like Arrow's theorem, we have the following unfortunate result. It is called the Gibbard-Satterthwaite theorem. And it states that any strategy-proof social choice function onto a set of at least 3 candidates is a dictatorship. We will only give the main ideas for this proof. If you are interested to see more details, please see the reference in the description. We start by assuming that F is a social choice function that is strategy-proof. We then construct a social welfare function, capital F, as follows. We start with an arbitrary voter preference. For a pair of candidates AB, we will move them to the top of the list while preserving their relative rankings. Then, one can show that F will always pick either A or B as the winner. If F picks A, then we will set A to be above B in the social welfare function, capital F. Otherwise, we will set B above A. And we will do this for all possible pairs AB, and we have constructed our social welfare function. Now, it is not obvious that this will give you a valid ranking of the candidates. So the first thing we need to show is that F is a total order. It means that it is anti-symmetric, which is easy to show, and transitive, which is harder to show. Then, F satisfies unanimity and IIA, and they are not hard to show. Since there are at least 3 candidates, Arrow's impossibility theorem implies that our social welfare function F is a dictatorship. And the dictatorship for our social welfare function capital F is also a dictator for the social choice function F. And that is the idea for this proof. Now, mechanism design for voting seems to be all bad news. Anytime you have good properties, the dictatorship comes along. But research has been done to find escape routes, which are ways to find strategy-proof mechanisms without the bad consequences. For example, One could restrict the set of voter preferences in some way. Another alternative is to introduce money into a voter's utility, and this has positive results similar to mechanism design for auctions. Of course, this is not practical in political situations, but it is applicable in other contexts. And that is the end of the lectures for this course. I hope you find this course to be interesting. We have covered a lot of different topics in game theory and only going into each topic briefly. There is so much more that we could not cover in this course, unfortunately. Perhaps you will see more of game theory in the future. But hey, that's just a theory, a game theory. Thanks for watching.